Hello guys, welcome back to Med Zone African Motives. We are still on our revisions as I promised. So this is another part of our trigonometry that is on 2D trigonometry. We've got a very, very important question that we can consider here. Let us see what we are given. This is a past exam paper. That is an exam question that we have on 4.1. We were given in the diagram below A, B, C, ACD and ADE are right-angled triangles. All right, so we've got the first triangle, which is referred as ABC. This is our B here. There is a B there. So it's ABC. That's it's right-angled at what? At B, all right? Then ACD, that is ACD, this triangle here, right-angled at what? At D, like this. I've got a right-angled triangle there. All right, and ADE, which is a right angle triangle, again, this one having a right angle at what? At D, like that. So that's a right angle triangle. So this one is a right angle, this one, and also. Then also we are given that BAE is 90 degrees from B to A to E, meaning to say if you join from B to E like this, you are going to have a right angle triangle BAE, all right? If you join, I'm not saying you're going to join there, but you're just given that it's what? It's 90. Maybe if there's a continuity you're going to join, we don't know. Then BAC is 30 degrees from B to A to C. We are given this angle as 30 degrees, this one. That's our angle BAC, all right? 30 degrees, this angle here. And also BC 20 units from B to C is 20 units, from A to D, it's 60 units. All right, then the question is, calculate the length of AC. So that is the first question, 4.11, to calculate the length of AC, and that is 2 marks for that. All right, so in order for you to calculate the length of AC, if you are to consider the right angle triangle from A to B to C, we've got a right angle triangle where there's an angle, because that's where we have the side AC. So we can't consider triangle ADE because we do not have what? AC there. So also we can't consider triangle ACD because we do not have any angle, just given this side, and inside we do not have an angle here. So this is the right triangle to use because we've got an angle and we also have a side. So I'm just going to take a sketch of the triangle that we are talking about here so that we can see what we are referring to. So I'm referring from point A to B to C. So that's we've got point A, point B, point C. That's a right angle triangle. And we said the angle BAC is 30 degrees. This angle is inside this triangle. This 30 degrees is for BAC. So we have got an angle of 30 degrees there. And here it's 20. And we are supposed to calculate the side of AC. All right. So that's 4.11. All right. So we're going to have this. So what are we going to do in this case to calculate the side AC? All right, what can we do? Remember, I said you name your sides according to the angle that you're given. Yes, you can calculate this angle. You have it at 60 degrees, then you use the angle of 60 degrees if you want. But just use what you're given straightforward, because we can name our sides and angles. Well, I mean, we can name our sides according to what we are given, this angle of 30. So according to 30 degrees, what is the side AC, the side that we want? All right, so this one, it has nothing to do with 30 degrees because it's what? The hypotenuse, the one that is opposite a right angle. So that there we've got a hypotenuse for AC, but for BC, this side of 20, it can be referred according to theta. They are opposite to each other. So the side of 20 is opposite to theta. So think of a ratio. All right, because we are only working with this angle of 30. So just use these two, one, what you want to calculate, and what you are given. So think of a ratio that consists of these two, opposite and hypotenuse at the same time. Do we have a ratio? Yes, we have from our SOHCAHTOA concept. Let us go back to our mnemonics. That is SOHCAHTOA. Let us check for a ratio that has got opposite and the hypotenuse at the same time. Opposite and hypotenuse at the same time are on sine. So we are going to write the ratio of sine. So it is the sine of theta which is the angle, is equal to the opposite over the hypotenuse. So I told you guys, you write down your formula, then you substitute what you're given into the formula where theta is the angle and our angle is 30 degrees. That is the angle that you used. Remember, you used this angle to name these sides. So you work with the angle that you used, all right, which is sine of the angle of 30 degrees is equal to the opposite. What is our opposite? Our opposite is the side that we are given of 20. So that is going to be 20 over the hypotenuse. In this case, our hypotenuse is the one that we are supposed to calculate, which is AC in that case. So it is going to be over AC. So you have formed an equation that you are going to use to calculate the value of AC. How are you going to do that? You can simply cross multiply, because this is same as over 1. So you're going to cross multiply. AC multiplies this side, this one multiplies this side. So you're going to have AC times 1 sine 30, which is AC. The sine of 30 degrees is equal to 1 times 20 this side. You obtain a 20. So in order for you to determine the value of AC, which is the side AC, you are going to divide by sine because you are multiplying. So you divide by what you want to remove this side because you are multiplying. So you're going to divide by sine 30. So this will cancel because they are the same, the sine of 30 and the sine of 30. You remain with AC, which is going to be 20 over the sine of 30. So there are we given the decimal part to use? We are not given in this case. So we're just going to use 2 decimal places, all right? So you're just going to use 2 decimal places. So it depends with the instruction that you're given. So mostly our answers are to 2 decimal places unless you are given another statement to use on that, right? So my calculator is already fixed to 2 decimal places. I told you guys how to do that. You go to shift setup, you go to the fix on 6, then you fix it to 2 decimal places, you press 2. So whatever that you calculate will be to 2 decimal places if it is a condition that you have what? A decimal. So this is sine of what? Sine of 30 degrees, all right? This one is going to give us 40,00, which means this one, it was giving us a whole number, this one. So let us go back to the normal mode at 8 and go back to the normal. So the number there is 40. So this one, it was not giving us a decimal. That's why it was 40,00, all right? So there, the whole, the number that we are getting there is 40. So meaning to say AC is going to be equal to 40 units in that case, all right? So we've managed to calculate our AC from the information that we are given. So like I said, if you want to use the sine, the angle of this one, if you calculate this angle, you're going to see that these are angles in a triangle, you obtain 60 degrees. It means these sides, they are going to change. You name them according to the angle of 60. This will be the opposite and this will be the adjacent. So please take note, use the angle mostly that you're given so that you don't have any confusion. Name your sides according to your angle. That's it. You fill in your information. So it means now we have this side from A to C. We have got 40 there, right? So let us see. Calculate the size of CAB. That is the angle in this case, all right? CAD, all right? CAD, the angle CAD, okay? So remember, so this one is not going to work for us. Let us just remove these guys. It's not going to work for us. So what is CAD? All right, that is 4.12, all right, 4.12. Let us just write it aside here, 4.12. So if we check, angle CAD is this angle here from C to A to D. That is this angle they are referring to. So you're asked to calculate this angle here. So remember, we can use trigonometrical ratios. Like I said, guys, trigonometrical ratios can be used for so many things, to calculate the sides, to calculate angles. So we can use the trigonometrical ratios again to calculate this angle that we do not know. Let's just take a closer look to say this was your theta, or is alpha, or whatever that you have. So we are going to take this triangle from A to C to D like this. This is the right angle triangle that we can use. So I want you to see, if we take it this way, this is like this. So we're going to take it from A to C, then from C to D like this. This is the triangle that we are going to take. So from this triangle, you're going to see that this is the point A, this one, the point A, which is to point C and to point D. And this is right angled at this point. All right, so we want to calculate this angle here. This is the angle that we want to calculate. All right, so let us fill in what we are given. Also, we are given AC. Remember, we calculated AC before. It is you who calculated this. You got 40 there. So meaning to say, if this value is wrong, it is going to affect you to calculate the angle, this one that you want to calculate CAD. All right, so make sure that you use correct values in your calculation. All right, so this is what you're going to do. We are going to calculate just like the previous case. Like I said, you just need a ratio that uses all of the given information that you're given according to this angle that we want to calculate theta. This side is the adjacent, the angle that you want to calculate, and the 90 degrees, they are adjacent to each other. So we've got the adjacent, then 60 is the hypotenuse. It is facing 90 degrees, our right angle. So there we have got the hypotenuse. So let us consider here where we have the adjacent and the hypotenuse at the same time from these ratios. Is there a case where we have the adjacent and the hypotenuse at the same time? Yes, we have on cos. So we're going to take our ratio for cos, write it as it is. Remember, the cos of theta, which is the angle, is equal to the adjacent over the hypotenuse. So you're going to fill in your information. That is, the cosine of theta is equal to the adjacent. According to this, our adjacent is given as 40. All right, our theta, sorry, let us fill in. Our theta is the angle that we want to calculate. Remember, CAD represents an angle. So we've got cos CAD, which is the angle, is equal to the adjacent. According to our triangle, the adjacent is 40 over the hypotenuse, which is our hypotenuse there is 60. So we can determine the angle. Remember, guys, I told you from the introduction, to find the angle, this one, you remove this cos, you write it on the other side as arc cos. So it means to find angle CAD, we are going to write cos on the other side as arc cos, like this, 40 over 60. So it's arc cos, which represents the angle. All right, so that's, you're going to obtain your angle CAD. All right, remember, and I just need our calculator here. So this is shift cos. To find arc cos, it's shift cos 40 over 60, or you can even simplify it, which is fine, or you can just use it as it is. It's still one and the same thing. So you obtain 48, this and so forth. So let us round off to 2 decimal places. So it's shift set up, go and fix your calculator to 2 decimal places, press 2. So it's going to be 48,19. All right, so this is going to be 48,19 degrees. All right, so that was going to be our angle CAB. That is how you're supposed to attempt this typical question. You just have to use your trigonometrical ratios. So as you can see, your trig ratios, as you can see, guys, it plays a major role in your calculations, a bigger role in your calculations. All right, so we've got angle CAD. Let us just substitute 48,19. All right, CAD here. So we got this angle 48,19 degrees. All right, let us move on to the other question. Now we are given to calculate the length of DE. All right, 3 marks for that. The length of DE, that is this one, the length of DE here. All right, if we were to consider where DE is, this side, we were supposed to use this triangle here. This is the triangle that we're supposed to use. All right, let us see. This is 4.13. If we were to use this triangle, we are going to see that we are going to have a triangle of this nature. All right, from A to D and to E, because we are using this triangle where there is what? Where there is DE. Remember, we want to calculate the side DE. So you have to consider where there is what? Where there is DE. All right, so you're going to consider where there is DE. So if we join here, it's going to be something like this to the point E. All right, so that's okay. Just a rough sketch, guys. Sorry for this sketch. Okay, but I just hope you understand what I'm trying to say. So this is your point A, which is, you're going to indicate this, your point A, your point D, and your point E, where you've got what? 90 degrees here at point D. Remember, I've got a 90 degrees there. You are given this side AD. You have it. You are already having it. So we have 60 units here. All right. And you want to calculate the side DE, which is this side, this one. This is the side that you want to calculate. Guys, if we are to take here, we are stuck. There is nothing that we can do to calculate this side. So what do? You go back to the information that you're given before or that you calculated before. Can I calculate or can I have any of these angles, either angle A or angle E? Is there a possibility of me having angle E? There is no way that we can calculate. E has got no relationship to any of these. So here I'm stuck. There's no way that I can do. All right, I move on to angle A. Is there any part that I can use to calculate this angle A? Yes, we have, because remember before we were told that this whole part of BAE is 90 degrees. From B to A to E, it's 90 degrees, which is this right angle here. And we calculated this angle. I mean, we are given this angle of 30, and we calculated this angle. So these angles, they are all supposed to add up to 90 degrees. All these angles, they are supposed to add up to 90 degrees. So what does it mean? It means that if I combine these angles, the angle of 30 degrees, all right, plus the angle of 48,19, all right, sorry for that, that's 48,19 degrees plus this angle, 1, 2, 3, all of them, which is, you can write as DAE, which is your angle, DAE, or you can just write as angle A, all right? If I combine these, they must give us 90 degrees because we are given that the whole of this is a right angle, which is what? 90 degrees. So if we add everything, it is going to give us 90 degrees. So we can calculate DAE in this case, which is this part. So what are we going to do? We are simply going to combine these two, then we subtract it on the other side. All right, so let us combine and see what we are going to have from these two angles. So the first one, 30 plus 48,19 like this, which is going to give us 78,19. All right, so this is going to give you 78,19 degrees plus angle DAE, which is going to give you a 90 degrees on the other side. So what you're going to do is to transpose this to the other side, take it to the other side. It is a positive here. So the moment you take it this side, it is going to be a negative. So you're going to subtract 78,19 degrees on this side, all right? So this one, you take it to this side, you subtract it on the other side, all right? So that means you are going to remain with the angle DAE, all right? This DAE. So therefore, our angle DAE was going to give us 90 minus the answer that we obtained before, all right? So that's 90 minus the answer that we obtained. We are going to obtain 11,81 degrees, all right? So this is the angle representing the angle of what? Of DAE, which is this one, all right? So we now have the angle inside the triangle. Like I said, we were stuck to calculate the side DE because we do not have any angle inside this triangle. But we managed to calculate from this part of the 90 degrees that we are given. So we managed to calculate this angle. Now we know that this is 11,81 degrees. So the moment that we know this is 11,81 degrees, what are we going to do so that we calculate our AE? Sorry for that, guys. Let me just remove this quickly. Sorry for this. So we are going to check how we are going to calculate our side from the ratios that we can take. So like I said here, remember we want to calculate DA. So we are going to check according to the angle that we just calculated now, which is the angle A. What is the side DE, the one that we want to calculate representing? They are opposite to each other. So there we have got the opposite. According to the angle of 11,81, we are going to say that it is adjacent to each other with the angle D. So these two sides, they are adjacent. So there's only one ratio that is got opposite and adjacent from our SOHCAHTOA concept. So there's only one ratio that is got opposite and adjacent at the same time. Which ratio is it? It is the ratio of tan theta. So that means we can answer our question now. Remember that the tan of theta is opposite over the adjacent, which is the tan of theta, which is our angle in this case, 11,81 is equal to the opposite over the adjacent. Opposite, which is the side that we are supposed to calculate, which is in this case, it's dA over the adjacent, which is your adjacent is 60 in that case. So you're going to divide to the adjacent. So therefore, you can calculate dA. Remember, all of this is same as it's over 1. So to find dA, I can cross multiply, right? So this multiplies this side, this multiplies this side. So I can just multiply direct 1 times dA, which is going to give us dA in this case is equal to 60 times 1 tan. This is same as 1 tan 11,81. So it's going to be 60 tan 11,81 degrees, right? So this is going to give us the length of the side DE. All right, so let us have this, guys, as our final solution. So this is 60, the tan of 11,81, like this. To 2 decimal places, we are going to obtain 12,55. So this is 12,55, like these units, all right? So it depends with the units that you're given. If you're given in meters, you write in meters. If you're given in centimeters, so there they just gave us as units. So you're going to write this dA as 12,55 units. All right. So that is what you're given. So that is how you calculate these typical questions. So as you can see, it's a stretching. We are stretching ourselves now as we are answering these question papers. On the introduction, we're just working with basics there. Now you are stretching yourself. You need to know everything from your basics. That's the first thing. Therefore, how to attempt typical questions like this. So we shall see as we are revising so that we work with more question papers as we prepare for the exams that are almost ahead of time. So make sure that you watch as much as you can, revise as much as you can, and don't forget to share our platforms to your friends and colleagues so that they also become part of the Maths Zone African Motives platform.